Hello, I'm Dr. William Schlosser, Washington State University, School of the Environment. This is my classroom.
Now we've got the first task here is called the woodland type tree characteristics. Okay, for this activity, it's an assignment with 100 points, but the real value of this is some core data that you're going to use in term report number 4. You need this kind of information to start to articulate when I'm standing on the south aspect, what tree species do I have? Well, as we saw on the field trip yesterday, it's very hot, very dry. We've talked about that photosynthetically active radiation beating down on the side all early in the spring, all summer long, right? It's still October, for goodness sakes. And yesterday it was very nice and warm. Beautiful day up there. But why does that beautiful mean anything? Well, it's because it's too hot, too dry for any other tree species except Ponderosa pine. Right, that is our leading indicator species right there. It comes out and sprouts and grows, reproduces on those hot and dry sites. That is its moniker. It is the hot and driest tree. Now it exists on some very wet and humid sites as well. Just at that barrier, it is the one who can live on the south aspect of Kamiak Butte, the south facing aspect. Okay, you go right over the ridge top and all of a sudden I've got Douglas fir there too. That's my number 2 species. Douglas fir is just behind Ponderosa pine on the dryness it can take. Now, it's another one of those species that can take a lot of wet. I mean, you go over to Forest, Washington, or Astoria, anywhere like that, there's Douglas fir all over the place. It's super wet there, right? We're in the rainforest. Yeah, it's a very mobile species in that respect. But for this Douglas fir at Kamiak Butte, it is our number 2 wetness species. Right beside and behind it is western larch. Okay, that's what we're seeing at Kamiak Butte, that north-facing aspect. That north-facing aspect has Ponderosa pine, Douglas fir, and western larch. You stack all 3 of those species in and you got a better mix. A little bit more biodiversity is set in here. Okay, so with that in mind, we're going to go back to the virtual reality site and we're going to tap into how we do the recording of these information. You know, what does it look like? What does it mean? But before we do that exercise in class today, I'm going to take another step here, go to the next task here, and it's called carbon sequestration. This is an assignment that is a little bit different for most. In this respect, we're going to use those same tree data that you collect in that tree capture information that we're going to walk through before the end of class today. We're going to do that. And then you're going to take a different Excel file. Okay, this one's listed in the resources down here. You can upload it to your machine, and I need you to change its name. Okay, put your family name and then a hyphen in the rest of the name, just so that when I pull them to my machine, because I do every one of the papers you write, whether it's in Word or Excel, I'm pulling it to my machine to score it. A lot of folks will say, "Hey, Dr. Bill, it didn't come through right. It looks wrong on Canvas." Well, yeah, it does. That's why I don't use it at all to view the files to score them. And that's back to my machine. Okay, so you're just going to give your original name on there and resubmit that file. I'm going to show you about this carbon sequestration task, what really I'm talking about doing here. You're going to process the data. You're going to be able to calculate how much carbon is sequestered in each tree that you sample. That tree sample is going to be used with an expansion factor to tell us how many trees per acre on that woodland type. There's a different number of acres on the north aspect versus the south. Okay, we got that. We can walk through it as well. We'll do that on the first assignment that we're going to touch, the one that's required. Now, this carbon sequestration assignment, I'm going to treat it as optional. Now, what does that mean? What it means is it's a lot of work. You got to push through it, and I'll give you all the basis to be able to create this. But the optional part of it is it's a 100-point assignment. And the students who've done this, even last semester, the average score was about 225. I had students nailing 250 on it. So you talk about a way to make that bonus factor, right? Maybe you missed a task earlier, you didn't do something else. Man, you can really rack it up with this one. I'm also going to give you a lot more time to get this one turned in. This isn't necessarily a big part of your term report, number 4. You can make it that way, but it's not obligatory. you can just step in and do these data analysis steps. Okay, a lot of files to download and look at, see what kind of information we have. Okay. That all said, I am going to go ahead and jump over to the very next one. So I think, yeah, we had the lecture number 17. This is the one that I asked you to watch for today. This is all about how we took the exact same field trip that some of the folks went on yesterday that we did in this case, it was the spring of 2020. Okay, right when the pandemic hit, right? Literally, we were the last university activity that happened at WSU in, what was that, March 17 of 2020. And then we were locked down, shut off. But we had the field sample analyses made. Okay, you saw the folks in that video. Some of those were TAs, some of those were students in the class, and some of the students in the class became TAs the next semester. So this whole progression, you'll see some familiar faces in there. But that was the process we went through to do the carbon sequestration determination. That analysis of carbon within the trees, I got to say, about 20 years ago, I had just returned from the Russian Federation with my doctoral dissertation information, the data I collected from trees and shrubs in Russia, right? I had plant samples and I brought them back with me, and I needed to put them through mass spectrometry to figure out what the carbon content was of each of those samples I brought. There was no mass spectrometer in Pullman, nothing. Ironically, I found it at the University of Idaho. Yeah, they had a system that they had refurbished and kind of made, repurposed it to carbon sequestration, and I used it. And so that was just 20 years ago, and that was something very unique and fine. To have it now here in Pullman and seeing kind of how we're doing all this, that lab manager, Jenny Carlson, she's at Johnson Hall in Pullman at WSU. She's a fantastic resource, and she did that sequestration for us. That becomes something that we can really take action on to understand how plants play this critical role in how carbon is sequestered from the atmosphere. That's going to be a lot of discussions we have in this class about this carbon sequestration, what it means and how it goes, where that carbon comes from. Hey, that's one of the biggest fallacies of life. A lot of folks who I think should know better don't really understand that cycle of carbon, how carbon is cycled through our planet. Okay, and I'm being kind of general in those terms because there's only one place that plants can use carbon. That's from the atmosphere. I got a lot of carbon in the ground, right? We have plants that die and fall in the ground. They're full of carbon. That tree bole that hit the ground, we were up at Cameo Butte yesterday. We see some of them were burned and they're laying on the ground. Okay, the detrivores are going to rot them away, and that is going to become part of the humus. It's going to be part of the soils. It's been happening for eons on time. But why do I bring it up? Because there's a lot of carbon there. It's in the soil. So obviously it's available to plants, right? Nope, not a stitch of it. The only carbon that a plant can use is going to come through its stomata, okay, its leaves, its needles. That is photosynthesis. Only by capturing carbon dioxide from the atmosphere. It's kind of a fun process, right? You pull the carbon dioxide out, you rip apart the carbon and throw away the oxygen. Us pesky mammals, we love it, right? That's how we exist, because the plants make the oxygen we breathe. The carbon is what the tree uses, or the plant uses, to make that woody fiber. That gives it the strength. Each plant species does it different, but that is carbon sequestration. It's going to hold that carbon in its stem. It's going to hold it in the roots. It's going to hold it in the branches and leaves. A little tiny bit is in the leaves because its biggest component in the leaves is nitrogen. Okay, then we got another atmospheric nitrogen load, right? About the fourth most common element in the atmosphere is nitrogen. But again, it's a slap door. Plants can't use a stitch of it. They got to get their nitrogen from the soil. That's going to come out of through the roots, up through the cambium, up through the xylem and phloem layers of the cambium. That's in the trees. That's in any of those woody plant materials. That's where they're going to get the nitrogen. It has to come from the soil. Carbon has to come from the atmosphere. Okay, that's going to be a theme that I need you to really key on a lot. That is the topic of Friday's lecture video. It's sitting right here. You get to see it and kind of feel it and do it. You're on it and you see the different parts of that introduction area. This is the entrance to Kamiak Butte. And we're going to click on the plants on the far right-hand side of this mix. Okay, when I click on plants, it's going to load up what you saw yesterday. Okay, this saw yesterday is going to give you the first north aspect plot. Okay, this one is a little bit different than the others, but what I just want to reiterate what Aiden was trying to demonstrate for you yesterday. It's more difficult to try to do this on your smartphone than it is on a desktop computer. So I'm on a desktop, obviously, and when I grab with my mouse and click and drag, this is looking up. This is seeing the top of the crowns of the trees. It's spinning in the circle, looking down and around. Okay, I get to see a lot of information with these tags of the tree numbers set out here. Okay, these tree numbers are what we're going to use today. Because I'm going to switch back very easily to say first sign is our data about the north and south aspect plots. Okay, when I grab those right here, I can see the data right here. My GPS location is 46 degrees north, 52 west, 117, 9 minutes. Okay, those are the data that when I step back over here to this first screen, I've already pre-entered them for you. So we're going to be able to verify this is what I have. This is what it shows. Okay, there it is. That's the elevation, the aspect, and all this. Now, a fun part of most of my field trips in the past is I would be up there with the students with the GPS on a staff. And that whole setup to say, why is this even important? Well, it's our place on Earth. How do we put here to be here? Okay, so these are the credentials, the things that we see, kind of link these things in. Okay, to get rid of that little window, you got to go to the upper right-hand corner and click that little X. Boom, it's gone. Okay, my first step now, when I click on tree number 1, I got to see that it's a Douglas fir. It's a couple of important components about this come into how we're making this plot data. This is called a variable radius plot. Okay, this is slightly different, or actually very different from what we traditionally use in forestry or any natural resources field sampling mantra. That field sampling will do stratified random sampling. Okay, we'll get out there and say, hey, this is one forest type. And now I got to decide how many plots do I need in this forest type to be able to make a representation of what really exists here. Okay, that means in this particular plot, we put in, or this timbers type, this north facing aspect stuff, I would put in about 5 to 7 plots. That will give me variability that I can do the statistics on those numbers. So I think most folks have taken a statistics class by now. If not, you want to take it because it's going to be the tool that you use quite a bit in your life. I know for myself, I've always fallen back on stats, not to be the big statistician, although really you become one just to manage your data right. This variable radius plot is different. We're going to put in one plot on the entire north aspect, one plot on the south. Those are 2 timber types. And what the process here is to say, put a plot on the ground, know its position, its accuracy. We got the start of that one. And then you're going to try to measure out to capture a distance that will hit a circle where at least 4 to 5 trees are going to shine. Okay, if you got those 3 to 5 trees right in that range, if you got those 5 trees, you're going to be able to make a variable radius plot statement about the trees that exist here. And that's really all that we're measuring right now. So this first one, its distance to the tree is 10.3. Okay, that is the distance to the tree. That's our radius. And that's what I'm looking for. How far do I have to go to capture 5? Okay, so with that said, I can jump back in. I'm going to try to minimize this little rascal right here. Keep that one shining bright. So Caitlin, Jasmine, tell me, are we doing okay with that? You can see both screens?
Yes.
Okay, so I'm going to step to the plot 1 trees tab right at the bottom of the screen. And now I see a bunch of stuff there that, really you say, hey, dude, that doesn't look right. We got divide by zeros and even number signs might appear. That's okay. That's because it's waiting for some calculations. If I step back to my characteristics just real briefly, I can see all that data was entered fine, but now you've got to enter a species. In this case, I'm just going to enter DF for Douglas fir. Okay, there's 3 species I want you to have 2 alpha character recognitions of. They're capitals D and F for Douglas fir. There's PP for Ponderosa pine and WL for Western Larch. Okay, but let's go back to this first tree now. My distance to the plot center is 10.3 feet. Okay, don't put in the foot marker. Okay, listen to me very clearly on that. You can put on that little hash mark right here, and all your data will turn into text. You can't calculate text. Okay, it's like saying I'm going to take Bill times Jasmine and get a result. You can't do it. Okay, that isn't what I'm looking for here. Just enter the numbers and strike enter. You notice that little hash mark just appeared. Okay, you see it right there. That's because I programmed it into the system to say, I'm going to let you enter the 10.3, and I know it's going to come in feet. And it'll put that hash mark on. You can jump over to the DBH. That's the diameter of breast height. Same deal here. Just enter the numbers. Don't hit the little quotes that look like an inch. Okay, but when I hit enter, boom, they're there. Okay, they're in place now. I can come over to the far right-hand side and I say, hey, that represents 131 trees per acre based on its distance from the plot center of where I stand right now. When I tap in the height of that tree, 105 feet, got it. Hit enter, same thing, no hash mark at the end. It's 105. It'll appear and show you that it's in feet. Okay, this is the process I want you folks to go through. Enter for every tree that you see on the spin around. Grab number 2. There, I got it. It's another Douglas fir. I can come over here and say the distance to the tree is 9.1 feet. Again, no hash mark. Tab over to number 2, DBH 13.1. My height, great, I'm at 92. You start to see what I'm doing here by building these out to say that I'm starting to amass the information about this plot. That's number 1 and 2. I've got them done. Now I just drag the screen around and I come up on tree number 3. Same kind of deal. Give that Douglas fir monitor, slide around. What's my distance to it? 15.6. My DBH 22.4. Nice tree. Height of 95. Okay, starting to piece these together. I hope you get the idea. And by the way, folks, this is where I want you to come in here to File, Save As. And if this were me, I would take this word name out and put Schlosser. This is what I want you to do. Not my name, okay? Don't put my name. I know some folks are very literal, but please just come in there and put your name on it and save it and keep it going now. Just keep building on it so that when you're done with this set, you're going to do the north aspect and the south. You're going to submit it. But the data you use from this is going to be more than that. It's the information that we're just about to finish right here. It's just that fast. I mean, I've been on this for about 8 minutes, and tree number 4 will have it done. We'll actually finish north aspect trees right now. Another Douglas fir. Its distance 21.4 away. It is DBH coming in at 21.4. Another nice tree at 95 feet. Okay. Tree number 5. Oh, we got a Ponderosa pine. So now enter PP for Ponderosa pine. Distance to the tree 18.7 foot. And our height 112. I got everything turned around wrong, don't I? Jasmine, you got to bark at me when I do something stupid like that, because I every semester do. So that's okay. Just change your data, make them right. 15.6, its height 112. Great. Now that one represents just 40. But again, it's not all the trees in this mix. That was right to there. Now tree number 6. Oh, we got another tree type. This one, Western Larch. Yeah, I got it in the right column this time. So we're going to come over and say its distance is 27.3 feet away. Its height 100 or DBH, I'm sorry, 14.6, height 105. Okay, that's giving us our variability of all the trees on the plot, except there's tree number 7. Great, same deal. It's a Douglas fir. The distance to the plot, distance to the tree 9.7 feet away is 23.7 inches. What a beauty. Height is 80 feet. Okay, now That's the tree data I needed from plot number 1. We got to add on to this plot number 2. We click the tab at the bottom of the screen, just beyond it on the right-hand side, and bang, I got it again, the same kind of deal. But in this case, we're only going to see Ponderosa Pine. So those species are all going to be the PP that I talk about here. But I'm going to ask you to fill that out. I want you to visit the site. You got to come over here and you'll grab this launch point right here to teleport to plot number 2. But still, I'm not going to quite leave it just yet. Got a few more things I want to ramble about this one. Okay, we see the plot numbers. And by the way, after you verify them once, you're going to see the check mark to say, okay, you've already done it. But now I'm going to come back to this Excel file. What kind of information do I have here? This is the kind of stuff I want you to put into your term report number 4. You're even going to be able to, you could step in and make this a table to put into your report. It's not obligatory, but it's not bad data to use. Another one is this right here to talk about your variability. This is a measure or a statement of your biodiversity on the site. What kind of diversity are we talking about? Well, it's just tree species now. But off of this, I've got the diameters and the heights. I've got their trees per acre, but individually, I don't really care. What I really care about is this one. I've got about 130 trees per acre as represented by this north aspect plot. Now, obviously, I could refine this a bunch by putting in those 5 plots and doing some statistical analysis to say, now I'm going to get the average trees per plot and average that to the entire stand. And I'd come up with a different number. But I'll say it's going to be in this range. It's pretty close. But what your statement will be for this term report is to talk about those 130 trees per acre on the site. I got one more thing I think I'm missing. How many acres is the north aspect timber type? Well, I'm going to minimize this for another step and maximize what I had here. And I think I can end that. No, I can't. Just got to go right back to there. Okay, back to the virtual ecology. I'm going to go over to my virtual field trip. Not there, though. It's going to be, you know what? I think I left that sitting nicely in our...
Mr. Bill,
Yes, talk
we
to
do
me.
have some questions coming in. Do you think you can go back to the Excel?
Back to the Excel, absolutely. Right here.
Okay, so Lola asked if it will like program the feet and inches like automatically.
It will put them in there as an indicator for you.
Okay.
You know if you're going to do the calculations that, hey, I'm dealing with on this one feet from the plot center. But showing that in, I'll tell you, I'll just show you real quick how I do that. I'm just going to right click with my Windows mouse here, and I'm going down here to format cells. Okay, with clicking that, it's going to open another applet window. This applet now, it lets me come in here to the number tab on this little applet to come to the bottom and make it custom. On the custom, I tell it right there to put a hash mark at the end of the numbers. So it's just for display purposes. It doesn't actually use it at all when it goes to calculate. In fact, by doing it this way, you're freeing yourself to use a number there. Even though for us, we get to see the hash mark saying, okay, I know that's in feet, okay, or the quotation mark, which I know is inches, right? So, but to do that, I had to come in and tell it back here on format cells. Same deal popped up, and there I've got it. It's showing it as inches at the end of the numbers. So that was just for pretty pictures. I mean, you could also put DBH in the word inches. But okay, I didn't do it. I shared it back with you this way. But I will say this, folks, every semester I got the same trip up that everybody makes. No, not everybody. A number of students make. And that is to put the hash or the quotations into their number. And for instance, watch what happens when I put 13.1 inches. Okay, I manually put in the inches and I hit enter. It immediately doesn't work just the same. Well, 13.1 isn't the good one to measure on. I want to get this 9.1 feet. There, I'll put in the feet marker and then see what happens. The TPA became a value statement saying, what's up with that? I can't calculate a word. Forget about it. That's like taking 10 times Bill. You can't do it. Okay, that's why I have this 9.1, and it automatically puts in that hash mark for you. So Lola, did that answer it? And everybody else, did you get the idea there? Don't put in the hash marks yourself. Jasmine, talk to me. Is that coming
And
clear?
then we have another question. So Mars is saying that the Excel equation for the TPA on their file isn't filling in automatically. Do you think you could show that so that they could see it?
It isn't. Oh, if you grab this file, yeah, if you grab this file before yesterday, got an earlier version of it, it wasn't calculated in. I updated this file last night for today's class. So that's where this formula up above here, you can see it right now. So if you have that previous one open, you just want to use it, this is the formula you just type in. Okay, literally what you're doing is you're using that distance from the plot center and 43,560. That is the number of square feet in an acre. Okay, that is kind of the mathematical runaround of the 43,560. If you're working with a lot of field sampling, you'll like remember that number as much as pi 3.14, right? We know what it comes from, what it means, but that's kind of the running number. And then I'm going to divide that by our C2, the distance from the plot center. That's my radius. Okay, if I'm going from plot center measuring out, that's how far I had to go to get to this tree, 10.3 feet. That's the radius of a circle. Okay, I take the radius squared times pi. And it took me, I got to admit this one, folks, it took me weeks to figure out how to make Excel enter the real value of pi. Not 3.14 with only 2 significant digits, but to take it out to that incessant, ridiculous number of unknown digits out there. Okay, it's just like that though. It's times pi, open parentheses, closed. Okay, boom, you got it. So that is the trees per acre calculation then. And that particular one, this is where I wanted to jump back around to our Canvas site. And I'll get us there right now because those data are sitting in our modules page for today. Okay, that's our trees per acre. I hope I left it here. Find out, otherwise it's on the carbon sequestration. Our TPA calculations, there it is. There's a PDF here. Bottom of that list, I'm going to give it a tap and open it for everybody to see. At least I hope it does. You tell me, Jasmine, when this appears on the screen.
Yeah, we can see it.
Okay, this TPA calculations, these are the very simple formulas, but if you don't have them, they're complex as can be. One of them is US standard and the other one for metric, but this is the one we're using here, the 43,560 divided by r squared times pi times your trees per plot, that TPP. Okay, keep that one in mind because the trees per plot, as we go back to that previous screen in Excel, right here I'm doing it for one tree at a time, but this one right here is the one I want to hit. That 130 trees per acre that I'm seeing here, it's in acres, I know, because that 43,560, that put it into the context of expanding this to that size. Okay, that means what I did is I had to take the farthest tree out in my group of 7. Okay, that group of 7 right here, the farthest tree out, I just went with the command says equals the max of C2 to C8. Boom, it picked out the 27.3. That became the multiplier for all the trees on this plot. Not one by one, but only in mass, right down here at the bottom. And I can break that apart to say I had 5 Douglas fir trees, which really represents 93 trees per acre. I had 1 western larch and 1 ponderosa pine. Now I got to tell you, the initial tack on this was to say we're going to push this out to about wasn't 27 feet. I think it was at 38 or 39 feet out. And golly, I had about 17 trees come in. Okay, we got a lot further out you go a little bit, the more trees you hit in mass because it just keeps getting bigger and bigger. You know that butterfly effect thing. You just a little change here and a little change there. But now I can give this representation. And the reason I really push it out as far as 27 feet is because I see what tree species I have there. It's a western larch. To get the biodiversity represented here, I had to go that far to get a third tree species. And it turns out I only got 1 ponderosa pine and 1 western larch. And when I push this out a little bit further, I got 2 western larch, 1 ponderosa pine, And I think it wasn't 5 Douglas fir, but something quite a bit higher. Desmond, do you remember what that was? You did it under the previous setup that I'm talking about here.
I'm not sure, but I'm not sure.
Yeah, it wasn't 5. It may have been something like 13 or 18. So there's a lot more entering of the data, but hey, we pulled it back and the process works just fine. We got the tree species per acre listed right here. So that's going to become a big theme as we talk about this term report. How do you use these data? Where are you going to represent it? This is your talk to describe that north-facing aspect timber stand. You can do the exact same thing when you step around to the south-facing aspect as well. But it's going to obviously be different tree mix and species and counts, different heights and different diameters. There's ways you can use these data to express a description of what the trees look like in that forest land type. Now, at the same time, you're going to step back around to, I'm sorry, keep this in mind. You're going to be able to use it. I wanted to tap back in, and I won't do it. I won't tap back into the virtual reality site just yet. But on that site, you can walk through it and find photographs of trees and plants and different soil types, quartzite materials scattered all around. There's plenty of shots appearing up there. I know a lot of folks yesterday were using their cameras, taking those pictures, being able to represent it. They're on the virtual ecology site as well. Download them. Remember to cite your sources. I'm really a stickler on that one, right? But that is going to be one of the things you can tap and then use. Before I leave this Excel file submission idea, this one, I just want to verify the woodland type characteristics, that Excel file, that's 100 points, and that one's due within the week. And literally, folks, I just went through all that gibber and jabber that I do, and in just several minutes, I got it done, at least half done. You got to do the south-facing aspect too. I demonstrated north, you're going to do south yourself. Get in there, follow it through, into the data, save it, your name, and submit that. Hey, that's 100 points.